I somehow on my PowerPoint I deleted some stuff. And they want to know, is the polygon convex, concave, regular, or irregular? So just to go over this real quick, a concave, let's do convex first. A convex polygon is just the normal stuff. Convex is the ones that we're going to deal with most of the time. So something that looks like this is a convex polygon. All right? Convex polygon, all it says is that all the angles inside here, they don't all have to be the same, but they're all less than 180 degrees. A concave polygon is a polygon that might look something like this, where one of the angles inside, or at least one of the angles inside, is larger than 180 degrees. Does that make sense? I apologize, I should have, that was supposed to be on my PowerPoint, and I think I deleted a slide and didn't mean to or something. I don't know how I did that. So, you said 27, right?
Yep.
So is 27 concave or convex? Concave. And is it regular or irregular? Irregular. Remember, if it's regular, all the sides are the same and all the angles are the same. If it's concave, it can't be regular. So it's irregular. Next question. Thirty-one. Says, find the length of each side of the polygon for the given perimeter. So they tell us the perimeter of this is 104 millimeters. Is that right? And how many sides does that shape have?
8.
8. So what kind of shape is it? Octagon? It's an octagon? Is that not what you said? I apologize.
I said X.
So it's an octagon because it's got 8 sides? What do we know about all the sides in this one? What's all those little markings tell us? They're all congruent? So what are you going to do with 104 to find the length of each side? Divided by 8. How about your calculator maybe? What's 104 divided by 8?
13.
13?
Yeah.
13 even? Oh, so it's 13, sorry, I forgot my units, millimeters. Next question.
33.
33. Let me erase all this. Does that say 4W minus 1? Is that what that says?
Yeah.
So if this side's 4W minus 1, what's this side down here?
4W minus 1.
So let's write that in. If this side's W, what's this side over here?
W.
And they tell us that the whole perimeter is 88.
Yeah.
What are you going to do with all these to find the perimeter? Add them all up. So tell me what to write down here for my equation.
4W
4W
minus 1
minus 1
plus
plus 4W minus 1 plus plus the W, so you're going ahead and adding them together. W plus W is 2W. And all that should total up to equal how much?
88.
88, because it's the perimeter, right? We're not doing the total of the angles or anything, we're doing the perimeter, so they told us the perimeter is 88. How are we going to solve that? Collect all the like terms, right? How many W's you got? So that's gone, that's gone, that's gone. Now we got a -1 and a -1, what's that give us?
-2
Was 88, now what?
plus 2.
Add 2 to both sides, that's 90. That's 10W, oops, ignore that.
Divided by 10.
Divide by 10,
9W. Or
W equals what?
9.
9. Now be careful, would they ask us to find?
The length of each side.
Length of each side. How long is this side?
That's 9.
9. So, what was it, 9 feet? So that's one of our answers.
The other side's 9.
This side over here is 9 feet. How are we gonna find these two sides?
Plug 9.
So 4 times 9 minus 1. Ignore that, what's that give us?
35.
So this side's 35 feet. And what's this side down here? 35 feet. Next question. 14. Is that an O or a Q?
Q.
It's a Q. Oh, it was, okay, we can't say. They tell us that TR is, what's this symbol mean? Perpendicular. So TR is perpendicular to TS. So what's that tell us about this angle right here? 90 degrees. It's a right angle. Ignore that. What's it tell us about these two angles together over here? They add up to 90. They're adjacent also. Anybody remember what's the special name you give to those two angles if they add up to 90 together? They're complementary angles. So we know this whole thing is a right angle, right? Let's see now, what else do they tell us? RTS, that's this angle over here, is 8x plus 18, is that right? What equation can we set up?
8x plus 18 equals 90.
It's just this equals that angle that we said was 90, right? So we solve that. Somebody be reading the problem again to make sure that we know what they asked us to find. What's 72 divided by 8? And they said just find x?
Yep.
So that's our answer. One more. Not sure why Michael's not writing that one in. Didn't like that answer? Didn't like that answer? Just turn the page in and write it down. Here, I'm giving you free answers when you do it.
16.
16. That's the answer to 14, Michael.
Yeah, I know.
So write it in the blank where it belongs. Why not take advantage of it? Says angle YZU and angle UZV are supplementary. What's it tell us if those two angles are supplementary?
They're equal to 180.
Oh, I'm sorry. So that means they add up to 180. This is just asking us, can we assume this? I should read the directions, I guess. So looking at our picture over there, let's see, this is, I'm not going to draw the pictures out completely here. Set a W up there. It's got another line going through here. I guess I might as well now since I've got it almost all the way done. That's a Y. That's a V up there. Did I miss anything? Oh, this whole thing here is a right angle. If that whole thing's a right angle, what's this angle on this side?
Right angle.
Right angle. They say grab this marker, I know you can't see it, but YZU. YZU. Everybody see that angle? Yes, no, maybe? And what's the other angle? UZV. UZV. They say those two angles are supplementary. Is that true or false? If they're supplementary together, they should make a straight angle, right? Do they make a straight angle? Yeah, so do we know that they're supplementary? So true or yes or whatever you want to write there, that's fine. Those two angles are supplementary. What are these two angles that I'm pointing at? Complementary, good. We already said this angle over here is how many degrees?
90.
90. What's true about these two angles? They're supplementary. They add up to be that straight angle, don't they? So they should add up to 180. What's true about these two angles? What's the special name for them?
Vertical.
The vertical angles, and they have to be equal, congruent. So if I told you this, if I told you this angle right here was 60 degrees, if I see that angle, tell me another angle you could find in this picture.
XZY.
XZY. How much is XZY? That's this angle down here. Be careful. Are those vertical to each other?
No.
VZU is 30.
VZU. This angle is 30. How come?
Is it equals to 90?
Those have to add up to 90. Then what?
And then you get 30 for that.
This one is 30 also. Then what?
30 minus 180, so
So YZU here is how much?
150.
150. How much is this angle over here?
90.
So I told you one angle in the picture, and how many of the others could you find? All of them. Make sure your names are on those. You're going to lay them right here. If you didn't grab the notes, grab them. We're going to see how this works. Make sure you're on the website. I don't know, trying something different, so.
Right there.
Classes here. Should be 4 pages up there. Try to make sure you keep them in order. That way it'll be less confusing.
It's not what you're doing.
It's not like you log in.
Hey, Mr. Ebersole,
Yeah.
whenever we finish a unit, can we get rid of the notes for that unit?
I wouldn't, because you know how math is, right?
Can we take them out of our binder?
You could, just I wouldn't lose them. I don't know that I'd take them out at the end of the 9 weeks maybe, because they need to be in there for the binder check.
You have a warning thing to be It is.
For a warning?
Try to see if you can create a new account and try to use something different and just make sure that you bookmark it.
What's the cost? Riley, try to use your password from last year. What's the cost of?
That's on.
It's in your binder.
It's right here. So, everybody to this point? Yes, no, maybe?
Yeah.
Colton, with us to this point?
Yeah.
I'm just kidding with you. I won't play that anymore. Does that make you mad?
No.
No, ain't fun if it doesn't make you mad. Do this. Click on browse your course. What module are we on? I'm not sure why they call them modules. What chapter are we on? 2. Go down to 2. Click the arrow out here. And it's going to have another drop down. Scroll down a little more. We want to go to lesson 4. Lesson 4. Does yours look like mine? No? What's it look like? Oh, it's not letting me in. Did you log in? Do you remember logging in back at the beginning? You might not have been here. Did you get done with that? You got it? You done with it? He's been, will you pass that over to him and? It won't let you in. We're not gonna use this a whole lot, so I don't care how many different names. I'm not using the grades and stuff off of here. So if you gotta re-log in, use some different password, whatever. I hope after a while that you don't, I don't wanna have 75 kids in one class. But just bookmark it and you should be able to go back to it every single time, right? So make sure you bookmark it this time. So everybody else's look like that? It doesn't look like that? What's it look like? Module 2, and then lesson 4.
That's what it looks like.
Does it have this?
Yes.
It's got launch presentation?
Yeah.
That's what we want to do, so launch presentation. Launch presentation. So we're going to deal with transformations today. A lot of just writing, filling in stuff. You're going to read quite a bit of stuff on your own. The first slide there, so you can scroll down a little bit. What is the picture? All right, it's that. If you, and I'm not, my camera doesn't do it, but the nicer, newer cameras, because usually my camera's a junk one, still not letting you in.
I'm in. I just can't find it.
All right. Hannah, did you get to where? You sure? Good. Huh? All right, so both of you go to, you see where it says browse? Click on the arrow where it says browse. And the little white box there in the middle. Browser, and go down to module 2. Don't click on module 2, click on the arrow, sorry. And then go to lesson 4.
Tonight?
Scroll down. Lesson 4. And then launch. No, maybe not. Hold on, go back up. Oh, launch presentation, sorry, launch presentation. Cameron, did they get you there?
Yeah.
Anybody else? We're all here?
No, we're on.
So what's this doing? And I started to say, if you got one of these new phones, you can do this with it. Like take a picture of yourself and then rotate it around, and it'll have you standing in a different spot, sort of like you're looking at yourself. I don't know how you do it. Again, my phone, I can't do it, and I don't really care to do it. But that's all this is. And what we're going to deal with is transformations. Anybody remember what are the 4 types of transformation?
rotation.
rotation,
Dilation.
dilation,
Reflection.
reflection,
Translation.
translation, all right? Now, as we go through these, we're gonna call them different names, like a rotation. Instead of a rotation, you probably called it what in the past? Instead of,
Flipping,
that's a different one. Rotation,
turning,
turn. A reflection
flip-flop.
is a flip. And then a translation, you probably call it a translation is when you just do something like this.
Slide.
A slide. So we'll probably use the generic names instead of using the big fancy names. Does yours, so yours looks like this, does it have this at the bottom? Next resource, so you're gonna click on that. We're gonna go to this next slide. Take just a minute or two, I'm gonna give you a minute or two. Read this and just try to mess with this. You can figure it out, and I will tell you, it says, select the shape from the menu, then press the add shape. I think if you go to that one, that's the add shape. If you like highlight your little arrow over it, your little hand or whatever, I think it says add shape and you can add the shape to it. So it's just that little line right there. Put a shape on there, you can add shape, read the directions, and just mess around with it for just a minute.
My computer's being dumb. It's not letting me do the next resource.
It's not letting you click on the next resource.
I don't have it at all.
Scroll down.
No, I
Maximize your. Scroll down now. Alright, close it. Anybody else having the same trouble? Launch presentation. That's why you went to that, not launch presentation.
Oh, thank you.
So take the shape.
Oh, that sucks.
Just move it around, do whatever. Now, as you're doing this stuff, when you get the EOC test, it has a graphing calculator on it, and you could actually do this. So if you're taking the EOC test and it gives you these shapes, you could get on there and actually do it. And then if you get good, like I'm looking at Jacob's here, and he's got this on there, hopefully he notices that he had A, B, and C as his original triangle, and then all of a sudden they put the little markings with the second triangle to name it. Oh my gosh. So it does all that stuff for you. Where you at now, man? Module 2, lesson 4. And then go to the, up there, yep.
Do that.
What kind of shape is that, Elizabeth? Not the triangle, the other one. Hannah, did you get back to where you need to be?
Hey, why can't I move this shape?
You have to hit add target shape.
I think you have to do something over here or something. You see this stuff here?
Uh-huh.
You also had to do what with that? I bet Kellen, I bet you read that, didn't you? I bet you read this stuff, didn't you?
No, I just click stuff.
Oh, start clicking. So if I add a shape, I don't know, I'll put some shape on here, four-sided shape, add shape, it's on there. Then it says, add a transformation, if you read the stuff up top there, which I've already read it. If we want to, I'm doing a reflection, so if I wanted to reflect it, and mine's already got a reflection on it. If I wanted to reflect it and do all that, so on and so on. I don't wanna mess mine up too much, cause I gotta reset everything on mine for every class, and that makes it hang the butt. So you can click here, it tells you, press pointer, then drag the vertices, so you could like drag it.
You can't drag the reflection.
Oh, you can't drag the reflection. I can't drag nothing,
Oh,
usually
that's
stuff, I
weird.
probably need to be back there on my computer.
Or you gotta click the pointer.
Okay. There. And it says, press add transformation, you can flip it, if I wanted to flip it over the y-axis it's at, if I wanted to flip it over y equals 1, y equals 2, so on and so on. So you could do all that. Notice it puts in this line here, that's the line I'm reflecting across. Also notice, if I click on each one of those, what's it tell me about them? What's it telling me for each point?
Their coordinates.
The coordinates, so on, so on, so on. Alright, click and go to the next resource. On the next resource, this is where you're gonna start filling in notes. So somehow have your notes sitting out there. Go through the paragraph there, fill in what you need to fill in. Click on that, it shows you what are they doing to the shape for this one.
Nice.
What kind of,
Oh, they're dragging.
what did we say it was gonna be called?
Sliding.
It's a slide. So they're sliding it. You're starting with your pre-image. The original shape is called the pre-image. The shape you end up with is called the image.
There you go, get a battery.
Yeah. It's pretty nice of me, though. So transformation is a function that takes points in a plane as inputs. So it's what you're given, that's what an input is. and gives other points as outputs. That's what you end up with. In a transformation, the original geometric figure, so this original triangle, the blue one or whatever color that is right there, is called the pre-image. That's what you're starting with. Pre means what you begin with. And the new one that they're getting when they slide out here, this green triangle, is called the image. Notice that when they slide this green triangle out there, A becomes A, and it's got a little mark on it. That's called A prime. A prime. All right? Branson, does that make sense? So each time you move something, you start with A. You can't put another A out here. It's got to have that little mark with it, that little tick mark. It's A prime, and B prime, and C prime. All the stuff that we're going to do, we're not going to deal with dilations right now, but everything else is a rigid motion. In other words, if I take this piece of paper and I rotate it here and then reflect it here and then slide it over here, did I change the paper any? That's all it means to be a rigid motion. A rigid motion means that the shape doesn't change any. So the triangle in this picture stays as the same triangle, it's just in a different location. Notice triangle, when we name a triangle, we put the little triangle out in front and then use the three corners of the triangle to name it. So triangle ABC. And when we move it to the new place, it's triangle A prime, B prime, C prime. There are three main types of rigid motions. Three main types of rigid motions. There are reflections, translations, and rotations. All right? And I'm just going to expand all these. A reflection. You can do this on your computer there and fill in what you need to fill in. With reflection. Do me a favor, and with reflection, we said, what's the other name? Oh, I'm sorry, they have it with you. You don't have to put it in. A reflection, another name for it is just a flip. So reflection is a flip. Notice if I let them do the thing here, it's reflecting it over that line that they gave us there. Sometimes we'll reflect it over the X or Y axes or whatever line we're given. And it's just reflected over. With reflection, you might want to put this down somewhere in your notes. With a reflection, when I jump this to the other side of this line, what's going to be true about the distance C is from the line and the distance C prime is from the line? The same. So if you're doing it on the X and Y on the coordinate system, all you're really doing is counting the spaces. How many spaces am I away from, if I'm reflecting over the Y-axis, how many spaces am I away from it? And then it's on the other side, it's going to be that same number of spaces, but it's going to be C prime or B prime or A prime. Elizabeth, am I doing any good saying all this, or am I wasting my time because everybody's writing and so everybody can do two things at once? They can listen and write. Mason, you can do two things at once. You can listen and write. All right. A translation. What did you guys tell me a translation was? A slide. So if we're just sliding this. Again, when you're naming a triangle, Ethan in, triangle, ABC. Use the three corners, and we're sliding it this time to triangle, the triangle symbol out in front like the angle symbol. A prime, B prime, C prime. When we get to a translation, we're going to do a lot of stuff with the translation. There's a lot of stuff that you have to learn for a translation because there's lots of different ways you can do a slide. A rotation. Rotation, we're spinning it around. Later on in the year, we'll do something with this, and we'll do it a whole lot more difficult than just on a coordinate system. On a coordinate system, there's a set of rules, and we're gonna go through those rules today. There's a set of rules that you have to use to do it. Alright? But if you're doing it freehand like this right here, makes it a whole lot harder. And I guarantee that when we start to do this freehand, if I draw a triangle here, and I say we want to rotate this 72 degrees counterclockwise, a whole bunch of people will end up messing it up, and it's not as hard as everybody makes it out to be, as long as you do the steps or the process to get it. So if I'm looking at this, think about it here. Identify two different transformations that we could have used to go from triangle 1 to triangle 2. What could they have done here to go from the blue triangle to the green triangle?
Reflection, translation.
They could have just reflected it over like this, or they could have just slid it over. Translation. All right? Click on the next resource. Sorry, I'm trying to keep track of my stuff here. Let's expand all of these. Pre-image. The pre-image again is the original shape. The original shape. Is there anything for you guys to fill in on this? I think it's at the bottom there or something, isn't it? Are you guys already past
Yeah, the
it?
next page, or like flip it,
Huh? And the next page?
Like on the back.
like on the back.
On the
of
back
it.
page. So the pre-image is the original figure in the transformation. The image is what you end up with, where you end up at. Rigid motion we talked about. Whatever the shape is, when you move it wherever you're moving it to, it doesn't change the size or the shape of the shape. Reflection, translation, rotation, we just got done talking about those. Looking at those questions there. Why do you need to know the images that are the pre-image and the image? How come you need to know which one's the pre-image, which one's the image? No reason?
So like the pre-image is before the transformation.
Alright, so the pre-image is where we start at, and
The image is after.
it's after you've done it. So that's why you need to know it. What are the three types of rigid motions? What were the three things that we just talked about? Reflection, translation, rotation. Alright? A flip, slide, and a turn. Which type of rigid motion moves a figure a fixed distance? So which one just moves this a fixed distance? A slide or translation. How can you change a figure's position without changing its size and shape?
Reflection.
All of them, right? That's what makes it a rigid motion. How can you change a figure's size without changing its shape? You can do a dilation, but it's changing the figure, right? And that's not what we want to worry about right now. Go to the next resource. Hope I'm keeping track of these. So on this one it says, and I don't know why they make this so big because you can't see the whole thing. Move through the slides to identify each type of rigid motion shown as a reflection, translation, or rotation. So we're playing this game here. Anybody know what game this is?
Yeah, game of life.
Is it Game of Life?
I don't know.
Yeah, it looks like it because it says it right there, I guess.
Oh.
So, if we're, where's our piece at? Probably up where we can't see it, isn't it? No? Oh, it's over there, that blue thing, isn't it? There, we can see most of it. You click on that button, what's our piece gonna do? Slide, right? So we just move it straight, it's a slide. Go to this, what's this? A reflection, everybody agree with that? You ever see something like that where you look into the lake and you can see the reflection down on the water? If your name starts with an M, then you probably walked on that part and tried to, thinking you were on the mountains and walking on the mountains and fell in the water.
Call me dumb.
Did I say your name? Next one, how about a pinwheel? Jacob begged his parents to buy him one of these at the pork festival a couple weekends ago. What's a pinwheel do?
Moves.
That's true, but how?
Circularly.
What is that? A what? A rotation. Go to the next slide, or next resource. Everybody with me to this point?
Yeah.
And the teacup ride at an amusement park. Notice they say just at an amusement park. Probably because they're not allowed to use that name. Riders sit in each cup, which turns as the ride itself turns. Identify the type of rigid motion shown. Click on the drop down here. Which one is it? Rotation. Click on it, and I'm not going to click on mine because again I got to reset all of this. If you click on rotation, then you can hit check answer. So tell you you're right. Let's see. All right, you're going to listen to Mr. Hardesty for just a minute. Here, just go. So you can bring it back. Can't hear anything Mr. Hardesty's saying.
Pretty.
I don't know. How would I know?
I don't know, Ann told me to ask you.
I haven't, I haven't been in this class for 5 periods.
That's crazy.
Kind of a W.
This is Mr. Hardesty. In our next problem, we'll take a look at transformation. Identify the type of congruence transformation shown in the diagram as a reflection, translation, or rotation. In our figure, we can see a tree, and opposite from that, in the water, is the reflection of that tree. How do we know?
Yeah, that was.
Somewhere here is the shoreline, which is considered as a line of reflection. That is, all points in the original figure are equidistant from the shoreline in this direction.
What's equidistant mean?
In this direction.
Equal distance.
Perhaps this point at the top of the tree, we
So
can compare
distances are the
this point
same, distances are equal.
at the top of the reflected tree. That distance to the line of reflection would be the same for those 2 points, and that would be the same for all points. So this is an example.
So if you're doing a reflection, what might be the easiest way? Instead of using a bunch of stuff, you could probably just do what? Count. Count how far it is from here to here, and put the other one that far much farther past the line of reflection, whatever it is.
What if it's like a decimal or something? Like
Yeah.
3.2?
Then you might wanna just, you might have to just estimate it. Or there may be, as we go on down through here, we may be able to use some kind of formula.
Okay.
Alright, skip on to the next slide. So identify each of these rigid motions. What's the first one? What is that?
Reflection.
A reflection?
And then
Translation? Which one is it?
translation.
Translation. Click on it and expand it and see.
We have to draw those.
Nah, not really. You could. It says translation. Is that what it is? So does everybody see that they just slid it over then up maybe a little bit? What's this? What's the B? Reflection. Everybody agree with that? And what's C? What are you doing with it?
Rotation.
Rotating it around.
I remember doing this. Actually,
Go to the next resource.
we did this in 8th grade.
On this next one.
We did this in 7th.
Answer that one. Do the drop down. What are they doing this time? Then check your answer once you do it. What is it?
Reflection.
Everybody agree? Reflection
Over the Y.
over the y-axis.
You watching?
Yeah, we might as well. Mr. Rutherford.
There's a lot of people.
Hi, this is Mr. Rutherford. In this problem, we will learn to identify congruence transformations. Identify the type of congruence transformation shown as a reflection,
Now, first thing, he said congruence. I'll say congruency. It means the same thing. Congruence transformation. All that's telling you is that when you do this transformation, what's true about the two shapes?
Same thing.
They're the same thing. They're congruent to each other. That's all it means. Congruency transformation.
or rotation. Notice here in the first figure that each vertex, and I'll compare this vertex here and its corresponding vertex. Notice that we have.
Well, you thought my voice would put you to sleep. This guy
to the left.
might be 10 times worse than me, Cameron. Could be.
And two means that,
My unit four is the same as that.
and this is consistent with the other vertices. So because of this, we can say that this transformation is a translation.
I think you're farther ahead of us.
Now let's look at the second figure. Notice here, that each vertex and image are the same distance from the origin. So we'll compare this
I don't know. Good.
vertex and this as well. The same distance from the origin. And we can also say that the angles formed by each pair of corresponding points in the origin are congruent as well. Notice that these angles here.
Were you in a different
and
class
the origin
No.
are
when we
congruent.
started?
So because of this, we're going to say that this is a rotation.
I'm not sure, Ethan.
In the third figure,
Everything else has been the same, right?
notice here.
You've been able to fill in the notes, or has it been completely
the same
different?
distance
Everything has
from
been
the
different.
x-axis. What is the x-axis? Now let's compare this vertex here
I just pushed it back.
and the image
Sounds like Clifford.
Notice that they're both
What's the
one
launch?
Yep.
from the x-axis. So because of this transformation.
Oh, you're on the wrong module.
Is called a reflection.
You're on module 4. It's supposed to be in module 2, lesson 4. Go to the next resource. check. What you're gonna do on this, it's gonna pop this up, it's got 2 questions. Go in there, take a minute.
It says,
Assessment.
It's not-
assessment viewable when assigned.
That means I gotta assign it.
Yeah.
What? Let's just do it up here. Let's see if we can just do it up here. What type of rigid motion you doing if you move this checker piece?
Sliding.
What is that? Translation? Yeah, I'm gonna have to click it, otherwise it won't work.
I don't know, I went to the wrong one.
Just hit question 2.
Yeah, let's just go to question 2, see if it'll let me. Maybe not.
Did it drop down here now? Right beside it.
What's this one doing? Thank you, Mike.
Rotation.
Rotation. So I'll have to figure that out. See, I'm learning as I do this. You normally hit done and review and it'd say incomplete because we didn't do it. I'm gonna submit it. Assignment submitted. Go to the next resource. Have to figure out how to do that. Did you figure it out, Ethan, up? Representing reflections. Reflections. Fill in what you need to fill in on this. So if you're reflecting across the y-axis, all you're going to do is multiply all the, I'm sorry, if you're reflecting across the x-axis first, all you're going to do is multiply all the y-coordinates of the points by -1. Then that's going to change it to where the image is going to end up at. So an example here. Scroll down just a little bit. If I take this segment here and it's 4,1, and I want to figure out where A prime is going to be, I just multiply that y coordinate by -1. So it'd be 4, -1. And that's where it ends up at. Now, a lot of times, instead of doing that, what do we say we're going to do? How far is the 4 above the x-axis? Or how far is point A above the x-axis?
1.
1. So how far below it should it end up?
1.
1. So you could just count, but you could also do the multiplication there. In your notes, there's an example, a couple of examples there. We're going to do them together, so look at those examples because they're not. Can everybody get this written down? That's the part you needed, right? Look at the 2 examples. They're not on the computer. It says reflect in the x-axis. That's just the way it's said. We'll probably say over the x-axis. The correct mathematical terminology is reflect in the x-axis or reflect in the y-axis. What do you got to do to -2, 7?
Multiply the 7 by -1.
So multiply the 7 by -1. So what's it going to go to? What's the new coordinates going to be for the new point? Be careful now. Do you change the 2?
No.
No, the 2 stays the same, so it's -2, -7. That's what we go to. It's that easy. How about if we reflect in the y-axis? What's that? And this was A. What's this point going to be called?
A prime.
A prime. Using that little mark up there. All right. Now for the second example, A is 5, -3 on the second example. What's A prime going to end up if we're reflecting in the y-axis?
-5.
You just multiply the x coordinate by -1. Those are the two answers for the fill-ins there.
Should there be a prime for that?
Oh, yeah, my fault.
Oh yeah, because
Again, if you're reflecting something, the easiest way to do it is probably just count. Count how far each point is from the line. So if this is my line, and this is my point, and it's 3 spaces from the line, when I reflect it over that line, it should be 3 spaces on the other side. Everybody with us to that point? Yes, no, maybe? Go to the next one. So it says triangle ABC has coordinates 3, 2. B is 2, -2. This is on the next page on your notes on the back or whatever it is, I don't know. And they want you to find A prime, B prime, and C prime. I think, yeah. This always bothers me because you can't see the whole thing. So I'm going to write these out here. Somebody help me out and read those to me. A is 3, 2. What's B?
2, -2.
2, -2. And what's C?
C is 4, -5.
And we're reflecting it in the x-axis. So if we're doing in the x, you got to remember it's sort of backwards. If we're doing it in the x, then that means you're multiplying the y by the -1. So now on yours, you can grab these and drag them and drop them where they belong. So do that real quick, and then you can check your answer. A prime they already did for you. Somebody help me out and tell me what B prime is going to be. If you multiply, what is it?
2,
2, 2. Anybody agree with that?
yeah.
You're just multiplying the y coordinate by -1, right? What's C prime going to be? Be careful now. Remember, you're just multiplying the y coordinate by -1, not both of them. Drag and drop those. And then check your answer. Did it work? Said it was correct? That's just giving you your answer. Scroll on down there. I'm not sure why they asked you to do it.
What are we on? Which slide?
This is number 12. And this is the next example. It's example extra 3 on your notes there. If we're reflecting in the y-axis, which coordinate are we going to multiply by -1? Just the what? If you're reflecting in the y-axis, what do you multiply by -1? The x. Remember, it's opposite, right? So we want to multiply each one of these x's by -1. So what's this x coordinate here going to become? Positive 9, what's this one gonna become?
Positive 9.
Positive 9, what's this one gonna become?
Positive 1.
So looking down here, which answer is the correct answer? C, is that the one we're going with? Click on C on there and then check your answer, see if that's right. Is it right or wrong? It's wrong? So which one is it?
A.
A? Is that what we're going with, A? So write these answers. That's what you need to write in the blank. Don't just put A, that's not gonna do you a whole lot of good, right, Cameron? You need to write the actual points, right? X prime, 9, 4, Y prime, 9, -3, Z prime, 1, -3. Hannah, any of this sinking in? Are you lying to me just so I'll quit talking to you?
Yeah, she is.
I think she is.
You should get right up in her face and then scream everything you just said to her. That'd be fun.
Next one, we gotta move a little quicker. Let's get a move on here. Check. We already figured out we can't do these checks, right?
Yeah, no checks.
So we'll skip over it this time. Next thing, translations. What's another name for a translation? A slide. Fill in what you need to fill in on this. I'll do this so that Riley can watch some motion there as he's writing down notes. Keep going back and forth. Keep Josie occupied and like the little mobile that Mommy's got above her bed to keep her occupied at night. You have one of those still? You don't have one of those little mobiles that spin around?
No.
Mr. Ebersole. Now you're gonna fire.
Yeah. Ethan O does.
Next.
You have one of those little mobiles, don't you? Above your bed. Yeah, probably.
I skipped over the check.
With the translation, I'll give you a few more minutes because we got to make sure that you understand this. Several different ways to write a translation. You got to know the different ways, and they're sometimes students seem to get confused by them. No. When you write this down. Does everybody see this? Not parentheses. This is called a vector. We talked about vectors earlier this year. This is how you represent a vector. So it's got those two things, and it's like a point. It's like the parentheses, but it's not. Whatever you need to jot down there to make sure you understand it, you might want to do it. When we're doing translations, when we're doing slides, sometimes they'll just tell you, when you were in 4th grade, 5th grade, whatever, and they just said, slide this shape. They might say slide 5 right and 3 up. So it may be written out that way. Just telling you how to do it that way. Another way is if I wanted to do that same thing, 5 right and 3 up, then I might write it this way. XY goes to x plus 5, so that means add 5 to each of the x coordinates. And then if I'm going 3 up, what am I doing to the y coordinates? So it may look that way. This is one way. This is a second way. The third way is to represent it as a vector. With the vector, it'll just look like this. 5, comma, 3. That tells you to move the x 5, since it's positive, 5 to the right, 3 up. What if I changed this and made that? Now what's the vector telling me to do? How many spaces to the right? 5. How many spaces up? None, because now it's telling me to do what with the y's? Go down. What would this tell me to do? Instead of moving to the right, now I'm moving to the what? Left. So 3 different ways to write it. Notice on this one they wrote it this way, 7, 4. What's that tell us? 7, 4 as a vector. What are we doing to each point? 7 spaces to the right and 4 spaces up. So 7 to the right and 4 up. Another way it could be written is, like I said here, you add taking the x plus 7, the y plus 4. Again, make sure you know we start off with p, so our new point should be p prime. Go to the next one. What's this vector telling us to do? What are we going to do to each x coordinate? Right 7 or add 7, right? What's this telling us to do to the y coordinates? Up 1. So tell me q. What's q going to end up? If I add 7 to that, what do I end up with? So q prime is going to be -1, -1. Everybody agree with that? Yes, no, maybe? What's r prime going to be? We add 7 to that, we're at -2. We add 1 to that, we're at -4. Do the rest of them and fill them in there and drop them real quick. See what you come up with. See if your answer is correct. Get it right? All this one, they already gave you the answers, didn't they? You weren't cheating and looking at that where you might. I thought we were dropping in the answers. We were just adding, putting +7, weren't we? Go to the next one. Is this on your notes? Is this example on the notes? Yes, no, baby?
I don't think so.
It's not?
No.
Yeah, it is.
Is it?
Yeah.
Where?
Oh, yeah, it's very large.
Where's it at?
Oh, yeah, it's there. There it is.
So it says MNP we got all those points, I'm not gonna read them all. What are we doing to each of these points of this triangle?
Going up four,
Up, no. Be careful.
right four,
Right 4,
down
down 9. Right 4, down 9. So if we were on a graph, we could just slide it and do that, right? But since we don't have a graph, we're doing this. So what am I doing to the 2? I'm adding what?
Four to negative two.
Adding 4 to negative 2. So what's that going to give us?
Two.
2.
Yeah. And then
And I'm
Negative.
subtracting 9 for each y, right? So
negative eight.
-8. What's n prime going to be? What's a -1 and +4 give you? 3. What's 4 and -9 give you?
-5.
-5. For p prime, 1 and 4 give you what?
5.
5. 2 and -9 give you what?
-7.
Is that one of the answers down there?
Yeah, C.
C? Does everybody agree with Michael on this one?
Yeah.
Write in those answers on your wherever there. What is that? And this is at the very bottom end. So just write in those answers there on the blank. Gotta know what this vector's telling you, and you gotta know that they could be written this way, could be just written out in words, could be written as a vector. Go to the next slide. This is another check, so we're gonna skip it. Says I gotta assign it to you first, so go to the next one. Number 19. Flipping over, fill in what you need to fill in on this real quick, and then I'm gonna pop up something else. It's on a PowerPoint that you have to fill in that bottom little chart there. Rotations are probably the hardest one. It's the one that takes the most to do. This book only does rotations, or most of them. They go counterclockwise. So counterclockwise is this way. In motion next time. I thought
When
maybe-
is our unit test or whatever?
Do what?
When is the like model 2 test or?
A little while yet. Why you in a hurry?
No. I thought it was soon.
We can make it soon. Ethan knows this yet. He wants it right now.
It's better now.
Let's go.
Last
It's better
time
to
he
not
act-
learn as much.
The last time he actually
Test
wanted to
it.
do like a project faster, it's because he cheated.
You would never cheat, would you?
Really?
He said you cheated.
From what?
I didn't believe.
And what?
On the project for Spanish, where you got the note card, post card, whatever it's called.
I mean, it's homework.
Yeah, we didn't have a project for Spanish.
He says it goes for
Well, we
everybody.
acted
Don't cheat
on
on homework, you're done.
Yeah, I couldn't use the sticky note.
Yeah, I know. And then you were like, actually, I don't want to do it faster.
When you're doing rotations, no easy way around it. You have to know what you're doing, know which direction you're going. So clockwise or counterclockwise, know how much of a rotation you're doing, 90, 180, 270, 360. Everybody always likes 360 because if I turn something 360 degrees,
It's the same thing.
it ends up being right in the same spot, right? So 360 is nice. You think I'm going to you do a whole lot of 360s?
No.
Probably not. But when you're doing these other rotations, no easy way around it. You have to use these rules. And if you don't write down these rules and have them right there in your box, you're not going to be able to do them. Rotations is the one where everybody always says, oh, I could just rotate it just freehand. I can do it. And it doesn't work. So if I'm going 90 degrees clockwise, what's happening to the point? What are we doing to the X and the Y?
Flipping, like switch.
Switch it, and then you do the opposite of the new second number. So if I have this, if this is point A, I don't know, give me two numbers for coordinate for point A.
6, 3.
And I want to go 90 degrees clockwise. A prime, watch so you understand this, so you don't mess these up anywhere. You've got to do this. You got to change it from A to A prime and go this route, then worry about graphing it. If you don't, you're going to mess it up. The first thing it tells us to do is switch them. So 3, 6. Then what do I do with the second number? You make it the, now look, this means the opposite. So if it started off being negative, you make it a positive. Since it starts off being positive, we make it a negative. So just follow those rules each time. And you got to do it for every point of whatever it is that you're doing. Again, with 360, what happened with 360?
It's the same.
It's the same. It doesn't happen. The others, you got to realize, hey, I'm flipping them, I'm flopping the two numbers, and then changing the sign of one or the other or both. Can you handle all that? The assignments on page 103. If you think you might need graph paper, if you want to use graph paper, there's graph paper up here. You can grab you a couple sheets. Might be helpful for some of you.